We've been talking about graphs, and now we're going to move to a certain kind of graph called a tree. So here in this section, we're going to learn about trees, define trees, and learn about some terminology that has to do with trees. So first of all, what is a tree? A tree is an undirected graph that is connected and has no cycles. If you take a look at the pictures here, you see that we've got a couple of different kinds of trees. First of all, we have what's called a rooted tree, and that's where we have a vertex that's possibly usually we put it at the top, that would be considered the root, and we can get to any other vertex by starting at that root. And we would have different edges coming down off of that root, and you see that it kind of looks like what you would consider a tree. Like when we talk about a family tree, that's kind of what it might look like. Okay, so that would be one type of tree. We also have another type of tree called a free tree, like over here. So that's where there's no particular organization of the vertices. We just have, some vertices and some edges, but we see here, as in this example here, we have no cycles. We could not ever start at a vertex and do a closed walk around it and get back to where we would started. So these are two types of trees, rooted trees and a free tree. We'll be talking mostly about rooted trees. So first of all, let's look at some terminology involved with rooted trees. So the level of a vertex is its distance from the root. So in this tree here, you see that this root would be P, because that's the vertex where we could start and then get to any other vertex by following along on the edges. So in this tree, P would be considered the root. Now the level of a vertex then is the distance from the root. So let's look at F. F here is one of the vertices here in the tree, and we would want to find out, if we want to find out what the level of F is, we would say, what is the distance from the root? And it looks like we would have to go along two edges to start at the root and get to F. So we would say that the vertex F is at level 2. Vertex N, we go over and find N, we see how many edges would we need to move on, what is the distance from the root, and it would be 1, 2, 3, 4. So the vertex N is at level 4. The height of a tree is the highest level of any vertex. So we would just look and see, what is the highest level of any vertex. And in this case here, we'd say it's 5, because looks like Q is the one that's got the furthest distance from P, and it's 1, 2, 3, 4, 5. So we would say the height of the tree is 5. Now we have a theorem that says this: let T be a tree and let U and V be two vertices in T. There is exactly one path between U and V. Okay, and of course, remember that in a tree there are no cycles. So this kind of makes sense, but anyway, that's something that we just are pointing out here. Within a tree, there's a unique path between any two vertices. Every vertex in a rooted tree has a unique parent, and parent, we'll talk about what that is here, except for the root, which does not have a parent. So let's take a look at an example here. So F, we would say, is the parent of E, and we can guess why, right? F is just one level up from the vertex E. We would say that E is the child of F. If F is the parent, then E would be the child. We also use the word siblings here. We could say that two vertices are siblings if they have the same parent. So we'd say that A, B, and C are siblings. If we're talking about a particular vertex, let's call it V, then we would say that every vertex along the path from V to the root, except for the vertex V itself, would be considered an ancestor of vertex V. So for instance, if we're talking about E, we would say that every vertex along the path from E back to the root would be considered an ancestor of E, except for, of course, E itself. So P, I, and F are ancestors of E. If U is an ancestor of V, then V would be called a descendant of U. So let's look at H. Here, if we look at the vertex H, everything along the path from H on, any path along from H on to the end there would be considered, any vertex along that path would be considered a descendant of H. So H has the descendants M, O, N, and Q. A leaf is a vertex which has no children. And so if we have a rooted tree and we put the root at the top, then the leaf would be those at the kind of at the bottom of any branch that doesn't have any children coming out of it. In this case here, we would say that there are 9 leaves because every one of those vertices that are circled there has no children. A subtree rooted at vertex V is the tree consisting of V and all of V's descendants. So if we're looking at the vertex F and looking at F and all of its descendants, we would say that that is a subtree. So here we have a subtree rooted at F.